Hello, welcome to the video on similar triangles. This is our third example set C. And what we're going to be doing here to answer the question, and the question is to find the value of the variable in each one of these figures, is we're going to be using that angle bisector theorem that we learned in the lesson. And if you recall, basically says that the angle bisector, like we have right here, is going to form proportional sides in this triangle. So this is actually quite easy to set up these proportions and solve for these variables. So let me go ahead and show you the theorem in practice. So what I'm going to do is I'm going to go y over 8. Okay, I'm going to go this way. I'm forming a proportion this way, and then I'm going to form a proportion going this way. Okay, and once you see the first problem set up, you'll be like, okay, this is actually quite easy if you had a little trouble with it in the lesson. So I'm going to go y over 8. Okay, y over 8 is equal to, okay, now notice I'm going from left to right. I'm going to go from left to right again, 21 over 14. Okay, so notice that these two, excuse me, are my numerator, and then the last two are my denominator. And then we got a simple um, proportion that we could solve using the cross product. So this will be 14y equals 168. Then I'm going to go ahead and divide both sides of the equation by 14, and I get y is equal to 12. So actually quite easy to solve the proportion, and hopefully by now these proportions are really easy. The key, as in anything, is knowing how to set up the problem. So if you understood this particular setup, then basically the rest of the problems are going to follow the same pattern. So let's move on to our next problem. So once again, we need to set up that proportion. So I'm going to go this over this. Okay, that particular expression over this expression. So this would be, let's go ahead and do it right here, 10 minus x over x is going to be equal to what? Okay, if you haven't done this, this is kind of like a little pop question. It's going to be equal to 9 over 6. I'm going this way. Okay, so 9 over 6. Now you need to go ahead and solve the proportion. Now remember here I had 10 minus x in parentheses. When you have an algebraic expression where there's a minus or a plus to a variable, you always want to keep in mind that these are quantities. So you do want to have those parentheses there. Kind of helps reduce the possibility of messing up on the distributive property when you have to do the cross product here. So let's go ahead and solve this particular proportion. So I'm going to get 6 times 10 minus x is equal to 9x. All right, so I'll get 60 minus 6x equals 9x. Now I want to add 6 to both sides of the equation. I get 60 equals 15x. And then, of course, x will be equal to 4. And I'm assuming, and I hate to assume, but this should be pretty much, old hat to you by now that you pretty much can set these proportions up, solve them, and you're really comfortable with the algebra. So this should be, and once again, I hate to assume, plenty of explanation on what's going on, how to get to our solution. Of course, if it isn't, you got to go back and review ratio proportions and whatever particular part of the equation solving that you messed up. Common problem here is a distributor property, but nevertheless, the key thing in this problem is the setup, okay, forming these proportions, all right, using the angle bisector theorem. So let's take a look at our last problem here. Okay, so this is just kind of a reverse situation, or the particular variable that we're looking for now is it's kind of like upside down from the rest of those triangles. But same thing applies. It's going to be this over this. Okay, so I'll do this right here. 14 minus x, okay, that expression over x is going to be equal to this over this. Okay, remember I'm going in this direction here. Okay, it's kind of a good way to think about it. It's kind of a directional proportional type thing going on. So 14 minus x over 12 over 9. Right, so let's go ahead and solve here. So this is going to be 9. Once again, cross product. All right, this times this is going to be equal to this times this. The product of the means is going to equal to the products of the extremes. Okay, so this is going to be 9 times 14 minus x is equal to 12x. So if you need to get your calculator out, that's not a problem. So 9 times 14, matter of fact, I'll get mine out here so we can work it together, is 126 minus 9x equals 12x. Okay, so I'm going to add 9x to both sides of the equation. And I get 126 equals 12x. And 9x, of course, is 21x. So 126 divided by 21 should give us our solution. And lo and behold, we get x is equal to 6. All right, so there you go. The triangle angle bisector theorem in action. It's a really neat and practical theorem. And as I've been saying before, especially with similar triangles, these are I don't know, for whatever reason, the SAT, all these standardized tests, SAT, ACT, etc., and teachers, they just love these kind of similar triangle problems because they test so many different things. One, they test and see if you understand the theorem, okay, and such that you can translate the diagram into a proportion, and then they're going to test to see if you know how to solve a proportion and you can handle the algebra all the way to get the solution, okay? All right, so hope you enjoyed the exercise. Keep working hard, and we'll see you soon.